Thank you for joining the March 5th, 2019 VOLTHA call. And this is our first week for Sprint 15 of VOLTHA 2.0. And do remember that we keep these the recorded meetings posted on YouTube, so please remember that during any discussions and presentations today. And I just wanted to check on my audio quality. I'm getting some odd sound on my side. Is it okay for everyone on the bridge? All right?
Sounds fine to me. Hear you.
Okay, good. Then it's just on my side. All right, then we'll go ahead and get started first with reviewing the JIRAs that have come in since our last review a week ago. And then we had a request for some time for Shad to go over the openolt data model. And then we'll look at sprint planning for Sprint 15, which kicked off yesterday. And with that, we'll go over to the new JIRA, starting with 1497. And let me get to the right screen. Oops. There we go. Okay. And the first one, 1497, model should prevent simultaneous or uncontrolled updates in a multi-core environment. And it looks like this one is being worked currently by Stefan. Any questions?
Yes, that's correct.
Okay. Thanks, Ken. All right, next issue is 1498. And this one is to enhance test libraries for use with various deployments. And Gilles, let me see if you're on the bridge today. It looks like this one's being worked by Gilles. And do we have any questions or discussion on this item?
I think is that Fahid from North Forge is here.
Hi, Sean, Julie, George, I'm here.
Okay.
Has Gilles joined? I think he's here. Yeah, Gilles is here. I was off last week, so I don't know if Gilles has any comments.
Yeah, this is complete. This is actually merged. This is a requirement from the SIBA group that wanted to use one of our test libraries, and so that was done. Yeah, yeah. It could be changed to done. Yeah, it was just merged now, just a moment ago.
Okay. All right. Good. Any questions from the group? All right, we'll move on to the next one then, 1499. Use pre-created topic instead of dynamically created topic. This is another one that has completed. And Ken, it looks like this one was worked by you.
Yes, that's correct, yeah.
And I think I'll go ahead and after the call map this one over to our sprint so that we can track the points there.
So, okay. So Ken, this is the one you talk about, the topic on the Kafka bus in the southbound of the VOLTHA, right?
Yeah, that's correct, yes.
Any other questions from the group? All right. Next item is Vol 1500, update VOLTHA OF agent to use PyVolta. And it looks like this one's being worked by Richard. And is this one, Ken, do you know if this one is expected to be completed in the current sprint?
It's likely to be completed in the current sprint. It depends on how far Richard move along with integration.
Okay, so I'm thinking probably we should map it in to sprint 15. Does that sound okay with you, Ken?
Yes, that's all right.
Go ahead and do that. And then put it in VOLTHA 2. All right, thanks. I forgot to ask for questions before we move on. Any comments or questions from the group? Okay, next one is a defect that was opened Vol 1501. PONSIM OLT is not receiving all packet out requests from the Go core. And it looks like, Ken, this one is done as well.
Yeah, that's completed.
Okay, any questions from the group? And then I'll probably map that one over afterwards as well.
I'm doing it right now.
Thank you, Sean. Okay. Next issue is 1502. Reconcile protos used in VOLTHA Go core with the protos in PyVolta. And this one currently does not have an assignee. And it looks like it was opened by William. Let me see if we've got William on the bridge. Or I do see Matt on. Do we have any comments or questions on this item?
Hey, this is William. Yeah, I opened that one. I'll sign that with myself because I'll do that as part of putting the protos in their own repo.
Okay. Great. I'll map that over to you.
Yeah.
And I should put this in Sprint 15 as well then, our active sprint?
Sure.
Or I'm asking more than is that the right place for it? Or is it too early to tell?
Yeah, I mean, yeah, I'll be working that pretty soon. So
you think you can get it done within the sprint?
How long is the sprint?
3 weeks.
Yeah, I think so. I'll be working on it.
2.5 weeks at this point.
Yeah, I'll be working on it before it ends.
Okay.
Sure.
All right.
Thank you.
I'm updating it.
Thanks, Sean. And then the next item, 1503, add a Get Membership API to the Go core to be used by the Affinity router. And this one was done by Ken as well.
Yep, that's completed.
Any questions from the group? Okay. And the next item, 1504, another defect that was opened. OpenOMCI does not encode day correctly in synchronized time request. And this one was opened by Chip and worked by him as well. Let me see, I don't see Chip on the bridge today. And do we have any questions we need to take back to him for this item?
We checked in a change yesterday and it's already merged in.
Yep, it's already merged in. It closed as done.
Yeah. So,
all right. Let me refresh to see if anything else came in. Okay, so that gets us up to current with a review of JIRAs. So next topic was a request for an overview from Shad on the OpenOLT data model. And Shad, I think I saw you on the bridge.
Yeah. Hi everyone. Julie, if you can give me presentation for just I just would like to put up a slide.
All right. You should have it in a moment.
Yeah. Can you guys see my screen?
Yes.
Yep. Okay. Hi everyone. So yes, I've been working on this for the past couple of weeks, and the folks who have been reviewing my commits, I think, have an idea of what this is about. But I had a request from someone to just explain what this is. So so I thought I'll just share this. So on the left over here is what we have today in 1.0. So again, this is about some changes that I'm making on the 1.x VOLTHA, and it's yeah, and hopefully this will help in the containerization effort eventually. But right now it's on 1.x. So on the left is what we have today on 1.x is core talks to the OpenOLT adapter or any adapter over the iAdapter interface, and the adapter that's coming north to south, core talking to the adapter, and the adapter makes quite a few calls back into the core through the adapter agent. And how this interface is implemented is that the core gives the device the adapter agent, and then the adapter is free to make any calls on the adapter agent back. And the keys, or how it addresses objects in the core is there's a lot of ways that it can do that. So it sometimes references things by the device object, sometimes with the device ID. Logical device similarly by either the logical device itself or the logical device ID. Ports are referenced by the port object, port number, port name. Similarly for the logical port. Sometimes ONUs are referenced by the device object or this device ID, or sometimes by the interface ID, ONU ID, or sometimes by serial number. So I think this is, I mean, and but if you look at the interface between the adapter and the device, this one down here, which is the openolt API, it is a bit more disciplined in the fact that things are referenced by, like ONUs are referenced by either serial number or by the interface ID and the ONU ID. Period. Nothing else. So the thing is that in the openolt API, between the adapter and the OLT, there are no constructs, VOLTHA specific or adapter specific constructs. Neither are there constructs specific to the hardware. So it's pretty generic. Now I think this is Matt and some of the people who've been porting over to 2.0. They've been feeling the pain of of this kind of an API, the iAdapter, which kind of uses several APIs which with differing ways to address objects, and I think they can attest to that pain. So what on 1.x I'm doing is introducing this thing in the middle between the core and the adapter, something called an openolt data model. And the data model, the interface between the core and the data model remains the same because we don't want to go and change the iAdapter interface. But between the openolt data model and the the kernel, between and the adapter, now the adapter is kind of being split into these two pieces. This interface looks very similar in terms of how it addresses objects to the southbound, so that's it kind of then makes this piece over here the changed kind of the core of the openolt adapter, agnostic to constructs of the 1.x core. Like the port objects, device objects, logical device. So now the new core openolt adapter, the kernel of it now, is dealing with constructs that are more standard, kind of or kind of represent physical objects. And all interactions with the adapter agent are encapsulated in this data model. So that's about it. That's the changes that I've made so far. They're not complete yet, but I think in a week or so, I'm again pulled into some. So and ONF, we are also trying to harden 1.x. So there are some issues with OLT reboot and things like that. So I'm working on that. But this will be complete on the 1.x probably in a couple of weeks' time. This also, as a side, also you can. There could be other future benefits to this in the sense that now that since this does not have any VOLTHA constructs in it, you could think of making a small standalone application over here, which kind of interacts with the openolt adapter over this new interface, and maybe a test application, for example. Or you could imagine this, you can imagine introducing a gRPC layer over here. And that would be easier to introduce a gRPC layer now because we don't have any, kind of device kind of constructs, VOLTHA kind of constructs. Introduce a simple gRPC over here and then have a gRPC application talk to it directly. So it kind of, I think, opens up a few possibilities over here. And so I've, the changes have, been, so far, if you want to look at the changes, you would see them all like openolt data model changes and get it if you want to go over them. So that's about it. If there's any questions, if not, Julie, over to you.
Can you go back to the presentation, please? So, I believe this is right now implemented in the 1.6 or 1.6 plus.
On the master 1.x.
Right, 1.x, and then so the OpenOLT. The first question: the OpenOLT data model, would that be part of the OpenOLT container, or or is itself as a standalone, or is part of the VOLTHA core? So where's the Kafka bus right now communicating in between? That's what I think it's still OLT and then the OpenOLT adapter, I guess.
Yeah. So again, this is not 2.0. This is still 1.x. Yeah. So
right. I'm wondering where's the boundary for
you would have to have a OpenOLT data model for 2.0, which is talking to the 2.0 core, to the proxy, the core proxy. So I believe if we take these changes over here, so this would then be the container. The OpenOLT data model and the OpenOLT adapter together would be a containerized, and you would have you would need to have a OpenOLT data model for 2.0, which is not talking a function level interface over here, not talking the iAdapter interface, but talking to the 2.0 core proxy. So this is
part of the change to 2.0 was to reevaluate the iAdapter interface and make changes to the iAdapter interface such that going over gRPC for containerized adapters, it made things easier. What I've just heard is, well, at least for the work you're working on, that objective seems not to be made because we're now introducing an intermediary, this object model intermediary. So what happened? Why the mix?
Yes. So no, 2.0 was never gRPC. 2.0 was Kafka.
The point, gRPC or Kafka, not really the issue. The point was the iAdapter interface was supposed to be modified to enable containerization. If that, and what I heard is that missed.
No, the problem here is that a lot of adapters in the 1.x core were written to take the old adapter agent, and usage was spread out everywhere in libraries, in various classes in the adapters. So now something that before was a function call away now requires getting the core proxy stub and using it. And all of that adapter agent sprinkling of usage throughout the classes now is a pain to sit there and have to sit there and move it over to new core proxy, because there's a number of places, even in places that may not even need core proxy usage, now has to be moved over to yield and then like callbacks to get to a core proxy function. If this were all wrapped up in one class, this one class being part of OpenOLT, other adapters could do it their own way. Then it makes it to where there's one place to go to interact with the core from within the adapter. So other adapters may do this, have already done this a bit differently to begin with, keeping the adapter agent call somewhat close to where it's most relevant. But in migrating, it became obvious that having some place to go to might make this easier. And again, this is just a class that's included in the OpenOLT container. It's not a separate function, not a separate component in the distributed sense. It's just one class to go to get to all your core proxy interactions.
So if I get it right, Shad, this is really a cleanup of the OpenOLT to make it a little bit more streamlined. Is that correct?
Exactly. So this is not enforcing another API for other adapters or anything. This is something internal. That is why I wasn't even advertising it, and I just had this call because somebody asked for a bit of explanation of what's going on. So this is all internal to the OpenVolt adapter. It's making the design a bit more cleaner, where all the northbound interfacing is restricted to a single place, a single class, and introducing a more disciplined API between that class and the rest of the adapter.
So I guess my question is that disciplined API something that needs to be rolled into the 2.0 version of iAdapter, I guess.
I think 2.0 adapter is pretty well reviewed and discussed. So
okay.
So that I don't have any issues with that. This is about
Okay.
yeah, this is about how we can reuse a core part over here of the OpenVolt adapter across 1.x and 2.0, and not have to, because 1.x is going to be around for 4 months, 6 months, or something like that, and it's a good place to test out things as well as we develop 2.0. So if we have this core piece over here that we can reuse across 1.x and 2.0, and keep the interaction with the core in 1.x and 2.0 restricted to this OpenVolt data model, where we have an OpenVolt data model version for 1.x and another for 2.0.
Also, because of the way logical devices are now handled in the new core, we can't interact with them directly. So with the new version or the modified version of this model, now we've got one place to go to either remove logical device interactions or rewrite them so that they make sense with the new core. Correct.
And this interface over here that is going from the OpenVolt adapter to the data model is I'm trying to keep it more like an indications kind of thing, because what happens is from the OLT from the OLT to the adapter, this is a gRPC streaming interface over here, where the OLT sends indications to the adapter, like OLT operation up, down, ONU discovered, ONU activated, interface status, operator status indications. So these are all indications that are going from the OLT to the adapter, and so I'm trying to bring about a similar interaction between the adapter and the data model, where this is mostly indications going up, rather than the adapter kind of querying things back from the data model or from the core. Because, for example, what happens now is the core makes a call, or something happens in the adapter, and the adapter just doesn't raise an indication up to the core. It does a few steps, like it gets the device and then it does something on it, and it happens in a couple of steps where there's a bit of back and forth where the adapter gets things from the core, and that's where the problems are rising, where you get an indication that something happened on an ONU, and then you fetch things, give me the device, and then you do something on the device and then update that adapter agent. This interface is a bit more closer to what the kind of indications that are coming from the physical device, where I discovered an ONU, so this would be an ONU discovery indication going up with the interface ID and an ONU ID, and then it's up to the data model to fetch the device from the adapter agent and do whatever to it, like set its status and then update the thing. So this interface over here is if we make it very similar to this to this one, then all the interactions with the core are restricted over here, and then it'll be easy for us to maintain a kernel of the adapter, which can be reused and which is future-proof to more core changes. Like tomorrow, a year from now, if we decide that the core Kafka is not scaling and we want to make the core and adapter interface a gRPC interface, for example, and I can see that happening. And so this part is not affected then. then we go and change this to interact instead of Kafka. We change it to interact with gRPC. Okay, I think that's I've taken enough time over here.
What about the ONU adapter side?
It's likely we'll have to do something similar there as well. Some of the work that Chip has done to break out some of the classes kind of already does this. We've kind of, I guess, between the Adtran adapter and the OpenONU adapter, have been carrying around copies of, or similarities between a lot of classes, and we may use this as an opportunity to make a common library for a POM port, and then the interaction with the core for updating that POM port may then go through one place. But yeah, I suspect we'll probably be doing something similar there as well.
And the other thing about the OpenOT data model, right? So for the alarm and PM should be irrelevant, right?
Alarm and PMs are interesting because they suffer from the same problem, but they're in the core. So not core, I'm sorry, in the library. So a lot of the alarms and statistics also have references to adapter agent within them as well for things that may not even need it. Just for getting basic device information, which could have just been passed in, has already been queried by the adapter or the data model in this case. Those classes have a full reference to adapter agent, which would need to be removed, mostly because it's not needed and it's a little bit heavy-handed to have to carry that around everywhere.
And the other thing that I wanted to mention is, which I have not implemented, is caching would then become, I think, possible in the OpenOLT data model, in the sense that the adapter, when it asks for something, given this is the interface ID, a common operation that is there in the adapter is given mapping the interface ID, ONU ID to the serial number or vice versa. Now, that's something that can be implemented as cache over here in the data model in a single place. So not implemented yet, but caching is something that can be a responsibility of the data model, and it could be like it could be that if the data model doesn't have it, it then is responsible for going and fetching it from the core. But if it has it, it will submit. Yeah.
Sorry. Because the example you list is, the serial number, interface ID, ONU ID is all ONU related information. What about the OLT, the device ID, logical, all those? You're saying all those, all those parameters will still kept on the interface between the OpenOT model and the adapter agent?
And I'm giving an ONU example because that is the one that has more examples of this. But yeah, the data model does the same thing with the OLT. The thing is, the data model instance is per OLT. So there's not you don't really have to reference different OLTs. So each instance of when you create an instance, when you pre-provision a device and we enable a device, right now how it works is in 1.x is you are creating an instance of this adapter class, and then you are referencing, and then you are also creating an instance of the data model for that OLT. So right now how it's implemented is the data model is it's not a data model for the entire for multiple OLTs, but it's a data model for a single OLT. So you don't have to really reference OLTs. But if you wanted to do it that way, then have a data model for multiple instances of OLTs. Then yeah, you would have a kind of a referencing mechanism over here where you say a serial number, and you would this thing, yeah. But yeah, there are constructs for the OLT as well, which are encapsulated here.
So
like the device information, the IP address, the device serial number, and everything is stored over here.
Matt, you were saying?
I was just saying that also, so interface ID, interface type implies also the NNI port and then the PON port on the OLT side. So querying and getting peer ports between the OLT and the ONU, this should also cover that as well. the relationship between ports. So it does, from what I've seen, include the OLT side information.
Right.
Okay. Yeah. Shad, I just want to double check. So the because on the abstract OLT we're going to have 16 OLT, right, on the serving per pod in some sense in AT&T's case. Then
Yeah, that's so far from this. Yeah, that abstraction is so far removed from this. It's there's a whole lot of XOS between that and this.
Okay.
The other thing too to keep in mind with the caching is the reason why that may become more relevant is in the old model everything was in one process and everything ran really fast because you're just a method call away from your neighbor class and its memory. Now that we're distributed, the call to go to Kafka to get a device, get a child device, or whatever, Kafka gRPC, pick your favorite. There's a penalty for distribution in that way that now things might take just a touch longer from a CPU sense than it did before. So things like caching may become more necessary at the per adapter level to keep things timely.
You mean the CPU of the X8 of the compute, right? So.
Well, I'm saying
right.
that in the sense of CPU execution time, when I'm in one process with one thread or multiple threads getting memory or accessing functions, before a call to adapter agent wasn't a actual network call. It was just a call to go get memory from a neighboring class in the same process to get something. So it tended to be pretty quick. The upside of monolithic is everything's right there. The downside, of course, is it doesn't scale. So we want to scale out, but the price we pay for scaling now is we have to pay a bit of price in API call timing. The caching may alleviate that, or should alleviate that.
And sorry if I'm asking all these questions. So for example, right, so if Adtran decided to use the OpenONU adapter, but they kept their OLT the way it is, that should work, right? What I'm saying
Sure,
is,
yeah, I mean, again, we all still need to conform to the core proxy set of interfaces, right? That doesn't change. So, adapter proxy to adapter proxy or core proxy to core, as long as we all conform to, the iAdapter interface or the set of RPC calls that core proxy makes available, it should all just work. The difference then is really now when you need to query devices or query things about the other device, how quickly does that happen? ONU indications being a good example. If those are flying in once every 5 seconds and you've piled up, let's say, 100 of them, now the timing of that might need to be considered. But again, we all conform to the core proxy interface, so then that should hold true for everyone. It's now internally within the process of OpenOLT, it can be organized so it's easier to get at that information without every class having to go directly to make core proxy API calls.
Okay, great. So another question is the timeline, and I think Julie probably going to address this one a little bit. So with this introduction, how much delay, how much additional time are we adding?
It's probably more like how much time are we saving? Right now, the price we're having to pay to go through and refactor to talk to the new core in the new way, it gets bigger as we keep digging into it. So right now, there's a number of classes, even in the library, that have calls to there that have to be cleaned up. So at this point, right now, we've gone through a first pass of modifying them to now conform to the new API call, yield when they need to yield. But there are others, and there will be a number of others that we'll have to deal with. If we have one place to put them all, and the sooner we can merge this in, it might help things. Yeah, I mean, in terms of adding time, we're going to spend the time we're going to need to spend with or without this. This likely will save time, but it's not going to cause us to spend more time.
Okay. And another question now, back to Amit. Amit, I don't know whether you are on the call or not, but maybe you're listening. Okay, I see you on mute. So, on the Go, OpenOLT adapter containerization using the Golang. So, do you have any comment on this one?
Yeah, so that was one of the reasons that I asked Shad to at least present what the concept is. because we definitely didn't have anything of this sort in mind. We were just following how the current Python adapter is implemented. So yeah, definitely we'll look into these changes and see how easily that can be done in the Golang version as well. But right now, whatever changes we have done does not take into account this concept.
Okay. And the chat, do you know when you're going to complete this on the 1.x?
So I think by the end of this week, I'm done with this. Whatever I had in mind. Yeah. Yeah. So the thing is, I'm also working on 1.x, some of the bugs on 1.x right now. But this would be complete by the end of this week.
Can the bugs hold on for a little bit and then get this thing completed so the containerization can move forward?
We can move forward without it. So don't think it's slowing us down. The big thing here with 1.x is there's a whole lot of other changes there, tech profile included, and there may be some of that rolled up in this as well. So we don't want to have to sit there and add more work by taking on a lot of changes, but we want to make sure if we do it once, we get most of it and we get it right.
Okay.
So on 1.x master, there's this stuff happening. There's basically the tech profile. That's the big chunk that's happening. And there are BBSIM is not on the VOLTHA master, but that BBSIM testing. At some point, there's after the tech profile work is done, we'll tag 1.x with 1.7 or whatever. And after all the testing is completed, and
so
that's sometime when
the tech profile brigade has is nearly code complete. So we are entering the integration phase and testing phase, and so when we run into bugs that are blockers, if we don't resolve them, then sometimes that integration work can get held up.
Sure.
Plus, we're trying to do things in an automated way. So if the automated tests get held up, then that helps no one.
And
so So what I'm trying to say is I'll be done with this by the end of this week, but I cannot commit right now to then taking this and migrating this into 2.0 immediately after that. If I'm freed up from 1.x some of the critical bugs, then I'll immediately get on to taking this and migrating it onto 2.0.
Great.
But that doesn't stop any of the work that's happening on 2.0. That doesn't stop anyone from referencing this if they want to take this and use that in 2.0. It's quite complete right now, code complete right now. There's just a few more things to add.
Great. Hey, Saurabh, so when do you think that tech profile and all those stuff can be demoed? For the larger crowd?
I'm thinking that by middle of March, we should be ready.
Okay, so potentially during the lockdown. Okay.
Yeah, oh no, definitely during the lockdown. Lockdown is, what is it? It's end of March, right?
Yeah,
definitely.
It will be.
Oh, of course,
okay.
Yeah.
Okay, any other questions? Sorry, I'm the one who asking most of the questions, but anyway. And Ken and David, on your side, since the interface doesn't change, I think so far so good, right?
Yeah, that's correct. It's the interface between the core and the adapters is not changing. Unless we see a reason to add new API stuff like that, but as for what I'm seeing from what Chad is presenting, that's not changing.
As part of our work, though, as we discover new things that we need to add to the API in the Go core, that change is made available for all adapters that want to plug in.
Yeah, exactly. If there's new API or that needs to be added or API that needs to be changed, obviously it needs to be done.
Yeah. So when I hear comments like, this OpenOLT data model is available for any adapter that wants to use it, I get that. That's fine. But now it's saying this is becoming the new interface potentially for adapters. And that hints to me, again, I've been away for a while, so I don't know all the details. That hints to me that there's a gap between the iAdapter interface and potentially an interface that is useful to adapters. And so that's what concerns me. That
no.
Is there a gap? Does it need to be identified? Or is this really just a simplification that's only going to be used by OpenOLT? We already highlighted in the discussion earlier that the adapters today have some level of interaction back and forth with the core, which had no performance issues when everything was one process, but we're seeing performance issues when we break it up into multiple processes. That also hints to me that, hey, maybe there's a gap there that needs to be looked at in terms of remoting that API. And so, am I against this? No, but again, I don't have all that much information yet. It's just, there's some interesting things that it triggers in my mind to think about.
And this is Julie. I know a number of us lost audio for a bit, so I think some discussion continued. Can everyone hear me now?
And now I had to reconnect.
Okay. And so I'm not sure how much we missed. David, I caught the tail end of it. Sounded like a discussion that was going on. So I'm not sure if we need to recap anything.
Yeah, I didn't catch enough of it, if at all
Okay.
possible. Can you restate what you were just saying, Dave?
I'll try.
Sorry.
So a couple things I heard in the conversation that raise flags for me, things that at least I need to think about. One was that this OpenOLT data model was presented because it gives a single entry point for communication to the core for the OpenOLT adapter and potentially other adapters. That potentially other adapters makes me think of this data model has some capabilities expressed through it that are valuable to other adapters, and thus we have kind of these parallel interfaces now. You could either go to the iAdapter interface directly, or you can do the OpenOLT data model. And that points to me that there's maybe a gap that we need to think about in terms of the iAdapter interface, that it may not be as simple, as efficient, whatever word you want to use, in order to write adapters. The second thing that got me thinking was during the discussion when it was mentioned that adapters today make a lot of calls back to the core APIs, if you will, and when everything's in one process, that's not an issue. You don't have any performance issues. But as we split things out into separate processes, that became an issue. Now that could be an issue with the iAdapter interface, that something needs to be expressed across that interface better, or expressed at all that isn't today. Or it could be that because how the original iAdapter interface was written, things became chatty when they shouldn't have been chatty. And maybe, again, that needs to be expressed in that new iAdapter interface so that there isn't back and forth. And again, I don't have all the full context, but these are just things that went through my mind as I heard this discussion. So I'm still a little, I'm not against the OpenOLT data model. I'm not saying don't do this. I'm saying, is this surfacing issues that need a little broader consideration in terms of the iAdapter interface, as well as the model of interaction between the core and the adapters? That makes sense? Don't have to agree, but does it at least make sense?
Yeah, it makes sense. So you're right about the fact that right now the iAdapter, I don't know whether the interface is chatty or whether the way the adapter, with the whole thing is split out, it is definitely chatty, and It's not like the adapter just is raising some kind of indications up to the core and leaving it at that. So just to let the core know about something, usually there are about a couple of calls that it has to make into the core, get something and then do something with it, and stuff like that. And I have not worked with implemented with the new 2.0 interface, so I cannot, I'm not. I mean, it's something Matt can say that is that less chatty interface than the iAdapter interface, but does that lead to a less chatty implementation? So yeah. I would not. I cannot comment on that.
I don't know if it's iAdapter interface itself is the problem. It's just in the old core, we got used to the idea of, for example, calling get device numerously and many times, or calling update device numerous and many times without really considering what it would cost, right? Before, you could call update device and it really wasn't that expensive, or get device many times it wasn't that expensive. Now that call does have to go and hit the wire virtually or otherwise to go get what it needs. Maybe the problem was we were using it too much before without considering it. Now we need to consider whenever we call those, how often we call them.
Yeah, and you mentioned cache too as part of, I don't know if it's part of this implementation or potentially part of this implementation. And then you have to start dealing with anytime you cache, you have to deal with TTLs or changes to the object that you have cached.
That's
method calls, and how would that cache get updated, right? So there's right. All sorts of those issues that raise concerns.
I've been thinking about caching, and I think that's the critical thing that I'm not able to that's stopping me from really implementing serious caching over here. Things that we could do is say that like for example the ONU device object. The OLT device cannot cache it, because it doesn't own it, and the ONU this thing. It can only cache stuff that belongs to itself, things like that. Or you could implement a listener in the data model where it's caching and it's also listening onto the KV store to get updates. So if that's implemented as a separate kind of a thread or whatever, it's not a load on the system, but in the background it's updating its cache. But again, there are race conditions that can happen. So caching is interesting. That's why this week when I was thinking of making some changes, it'll be some very minimal caching that, for example, the OLT, definitely the data that it owns and will never be written to by either the core or by the ONU adapters. That can be safely cached because nobody else is going to write to it.
Yeah, I guess what I had envisioned was that when an operation gets passed down to adapter, at the invocation of that operation, all data that operation needs is available, and then it becomes just a run to completion exercise. And so that once that kind of invocation happens, there shouldn't be any back and forth with anybody, right? I have all my data. I run to completion with that data. So when you talk about a chatty interface back and forth, whether that's by a design issue or whether by an implementation issue, that concerns me a little bit, because it goes against what I was thinking was kind of a run to completion model.
That's right. For example, the interface between the adapter and the physical device is a run to completion. Every time the adapter makes a gRPC call to the OLT device, it gives all the information that the OLT device needs, and the OLT device runs to completion, whatever the things. And it never asks. And there's never a gRPC RPC going back from the OLT to the adapter. And that's the kind of stuff that at least I would like to see happening over here, where the core gives something to the adapter, and that's it, and the adapter can then take it from there and go on. But it's not there right now in 1.x, and I don't know about 2.0.
Yeah, that's what I'm wondering.
Well, in 2.0, the core, when you make a request into an adapter, it actually provides it with all the information it needs. Like I said, if there are some APIs that there's some data that are still required, then we'll have to modify the interface to provide that additional data. But coming back to chat interface, because we have those APIs available of a core talking to an adapter and adapter calling back into the core, there's nothing that prevent an adapter to continuously use that interface, like Matt was talking about, update a device. Well, if an adapter choose to update a device like 1 million times, there's nothing we can prevent it from happening. So it's really more like on design principles and on implementation. That's how we can limit those kind of chat interface.
I agree. I think part of the problem is a bad design on the adapters. I mean, some of them have been copy paste from earlier versions. So yeah, I think 50% or whatever the problem is that of the chat interface is a design problem.
Yeah, and I just want to make sure that we don't start changing cores or even implement this data model to facilitate that bad design problem, because, well, that might hide a symptom, but it will definitely come back and bite us later. So I'd rather see us spend, where there are design problems in the adapters that keep them chatty, I'd rather identify those and work on those and have someone work on those as opposed to hide the symptom, because I'm really afraid it'll bite us in other ways going forward.
Yeah, and that's part of what we're doing now is, even without the data model in place, we're finding calls made to, like, say, update device now that are just either unnecessary or just spurious for no reason. And I mean, an example where the requests don't come from the north, a lot of times, like OLT indications are a good example that kick off a lot of activity. The OLT device itself sources an indication, it gets to the adapter. The adapter has to fill in a lot of blanks about certain pieces about that child device. Go and ask the core, do you know about this child device? And if it doesn't know about that child device, add that child device, and then take that and then actually talk back to the OLT hardware again about activating and enabling it. Just that one conversation right there was a lot of south to north, ask a question, north back to south, and then north to the adjacent ONU adapter to kick it off as well. In that case, it's not just north side for API talking to the adapter saying, here's everything you need, go. It's more of I have the adapter with only part of the information it needs, and I need to go to the core to get the rest.
Yeah, and I've seen systems, large distributed systems, where if there is a distributed component responsible for a given entity, that information is given to that distributed entity either on change or periodic basis, such that, when an ONU indication comes up, it doesn't have to go ask the core. The core's already told it somehow, here are the ONUs that you're responsible for. I'll let you know if any of them change. You kind of keep those cached locally. And that's where I've seen some caching happening. And depending on the frequency of change, that can work. If the ONU description at the core doesn't change very frequently, that's maybe an efficient way to do it. If the ONU description at the core changes frequently, then you got you've just changed where your chattiness happened. You're still getting a lot of network traffic, which isn't good for a distributed system necessarily.
I'm going to do a quick time check here.
Get back.
Go ahead.
Yeah, no, Julie, I think we should take it back. Yeah.
Okay, I'll take control back. So I think this is good discussion. We needed to have this discussion, and I think there needs to be follow-up as well. So I wanted to check with the group having the discussion at this point. What's our best path forward here? Do we need to schedule a separate meeting, an additional one to continue dialogue? Can we use VOLTHA discuss initially? What's the view from the group? Okay. I'm hearing. Oh, go ahead, Chad.
Yeah, I think I don't see. I mean, they're all good points, but I don't think we can sit down and resolve them. So I think I prefer us getting more and deeper into implementation, and like Matt is already doing that. If once and as the people who are developing this are aware, we have raised some good questions, and developers who are going to work on this, I think they can bring up these issues in them as they start implementing and come across them. I think so, but if you think we need a further discussion, okay.
Julie, I think
my comment was going to be, you know, I raised the issues. Chad, Matt, they're smart guys. They probably already knew about them.
Okay.
Do what they need to do.
All right.
My point is potentially both tracks should go parallel, right? I think if I adapter chatty, I think there are things can be done on that end, and I think I do think it shouldn't be waste of time, you know. So it could be happening. What I'm saying, you know, going forward with the new data model does not mean we're not going to address the adapter issue. So I think let's move forward with.
Yeah, I mean, at this point, we keep moving forward with what we're doing, and what we're finding is as we make a lot of calls to a lot of common functions, if it becomes clear that instead of calling this thing 15 times, if we can ask one time, or even better, be told one time, then we'll bring it up as we find it.
Yep.
Okay. All right. And we've got 3 minutes left now, so I think what we're going to have to do is defer the bulk of the discussion on the sprint planning. So we had a lot of issues that fell out of Sprint 14 and carried over into Sprint 15. So not much new there other than new tickets that came in that we reviewed at the start of the call that were brought in, and some of them completed already since our last meeting. So we can take a look at that. What I do want to make sure we have some time to talk about this week, so I think it'll probably be on Thursday, is where we are in terms of schedule. Because at this time, we had planned, our thought was with adding sprints 13 through 15, that we'd be able to complete the tech profile work, the containerization of the ONU adapter, and the first phase, at least, of the openolt adapter Go-based containerization. And since this is now the last sprint that we had planned for 2.0, and it'll go through March 22nd, I wanted to get a sense from the people working on the various development sub-teams for the key scope items on where we are on that track towards completion. And to give me, if we could maybe between now and Thursday, so we can talk about it on Thursday's call, if you can give me an estimate based on the current resources working in the brigades, for example. I think we heard from Sarah, we're almost done on the 1.x branch for the tech profile work, and there's some integration testing underway. I need to get a sense, if we can, on where we are in terms of timeline for the adapter containerization, how much more time is required, so we can take a look at the plant schedule, see if it makes sense. So I'll ask folks for a little homework on that. If you don't mind, we'll defer this discussion to Thursday's call. And let's see, there was one other item I wanted to mention, and now I can't remember it. Sean, do you remember? I think we've got a minute left, so I'm blanking out now on what I wanted to cover.
So maybe I just wanted to say that if you, Sean sent out a form for the lockdown. So even if you're not planning to attend, please fill out the form. There's a survey question at the end, and you can even specify a T-shirt size that we can, even if you're not coming to the lockdown, we can get it to you later on. So please do fill out that form. Thanks.
Thanks for that, Sarah. Okay, I think we'll go ahead and wrap up for today since we're out of time. So I mentioned briefly the schedule for Sprint 15 goes from this week through March 22nd, so it's another 3-week sprint. We'll talk about more related to the schedule and getting updates on status for the various work efforts underway on Thursday's call. And with that, we're out of time, so I will drop the bridge. Any last questions before we end today? Okay, I will stop
on Thursday.